Hello again, it's tubalcain, your YouTube shop teacher. And in this video I'm going to show you how to make a die holder that will go into the tailstock of your lathe and will hold hexagon dies, small 1-inch hexagon dies. And if you watch my recent video 553 where I made these hexagon handles with metric threads right here, and I did that on the lathe, and since my metric set consists of hexagon dies, I really had no decent die holder for that, and I struggled just a little bit. And I'll put the link up here where you can refer to that other video if you want and show you just a little clip right now of what I'm talking about, a real short one. And then I'll meet you over at the bench and we'll get started. How about that? Let me show you what I'm talking about before I get started. Often I do threading like this on the lathe, either under power or by hand, with a die, not single point threading, but with a die. And if there's a small 1-inch round button dies, I hold the die in the tailstock in this type of die holder. That's a homemade one, and here's a pretty nice one that's commercially made. It's old enough to where it's made in Japan. It's an import, but it's a nice one. And notice they're hollow all the way through, so that you can get fairly large stock through it without bottoming out. And when I use 1.5-inch dies, I use this die holder. You've seen this in other videos, and this one was made by Cleveland Company, and I had turned it down here at one time so it would fit in a 1/2-inch chuck. So then what's the problem, you say? Well, when I use the Ace Superset metric, this is strictly metric, all of the dies are hexagon. Now I have hundreds and hundreds of round dies in both 1-inch and 1.5, and I do have some hex, but this is the typical hex holder that you're going to see in these sets. And again, these are all metric, so how are you going to hold something like that? You can't fit a hex into a round hole. As I said, these are 1-inch across the flats, so they can be held in a 1-inch hexagon socket. And I prefer, this is a 12-pointer, I prefer 6-pointers. I didn't have any. Those would be impact sockets. But I do use one of these in a rather crude fashion in that video. And let's take a real look at a clip of that right now. Cut away to that. Alright, I'm back. Do you remember Jim Deadman? And he has a channel, check it out. But he sent me several of these, and he made up handles for some of my Kurt vices. But he used that method where he essentially took a socket. I don't know if he softened them or not, he didn't tell me. But sliced them off, a 6-point, rather than a 12, and I don't know if they're pressed in or if they're held in with Loctite or what, but that makes a pretty nice job, and that's what I considered doing to make one of these. Well, then I also considered sacrificing one of these, but you know, they've got that collet business on the back, and I have several of these, probably 3 or 4 of them. Notice that here's a little one in the smaller size. I never have used that. That holds this size. But anyway, that's what I was going to do, but then I would have to machine it on this side too. So I searched and searched the premises over and over, and finally I found an old box of taps and dies and die holders that my neighbor Tommy, you know, Tommy, the owner of Smoky, gave that to me when he retired, and in there is a foreign-made hexagon die stock that'll hold 1-inchers. Now, of course, it's zinc, but so is this. But my plan here is to amputate the handles, turn it round, and that'll give me a little bit thicker wall space. And then I'm going to insert this into a holder that I make in a fashion similar to Jim Deadman. So you follow what I'm doing? Now this Japanese one is 1.5 inches in diameter. Kind of surprises me because it was made in another country, but it's 1.5. And so is this one for that matter. But if I would turn this down, clean it up, turn it down, it's really equal to about the same diameter, see? So I have to start with larger stock. So I will start with 2-inch. It's a little bit under 2-inch. I know that's an odd size. But I'm going to start with that, and you can see there's a lot of machining to do on that. But I'm going to begin with, and then I'll follow the dimensions of this, other than the diameter here will be larger. So this isn't really very original at all, but to my knowledge, you cannot buy such a thing. Or I would just go ahead and buy one and not go to all the trouble. Now watch some viewer tell me, hey, you can get those from so-and-so. But I'll start by sawing these off right now. I'm not too worried about trying to get this hole lined up with anything, because I'm sure that's a metric thread, and at some point I'm going to convert to probably a 1032. But see, that's die cast, and it's kind of nicely made, really. So let's saw it off. It's Milwaukee time. Now be sure and wear your safety glasses and work safely in the shop if you would. And that's what I'm going to use. Now I need to turn this down round just enough to clean it up. I don't really care what diameter, just so it's cleaned up. I want it as large as possible. You know why it takes so long to make these videos? I spent so much time looking for things. But my idea here was to hold this on the end of an appropriately sized piece of hexagon stock while I turn it in the lathe. Well, I don't have any hex that size. I had some 7/8 and 3/4, but nothing, and 5/8. So then I thought, well, I've got a hex bolt. I got 1,000,000 bolts, so I go out in the coal garage, and I could not find a bolt the right size with a 1-inch head. So I don't know what size bolt that has to be, but I didn't have it. So I took a much larger one and put it in the hexagon collet block and milled it down so that it is truly 1 inch. And this will be, I guess you would call my mandrel or my holder while I turn that down, and I'll put a bearing or something up against this to press it in so that it can't come out as I'm turning. Let's go over to the closing lathe. I took this over to the belt sander and sanded it down a little bit, because if it's too irregular the tool catches on it. I think you know that. But it's going to go on like this to the bolt. But I told you I need something to hold it up against. Well, I made this way back when I was in my prime with a ball bearing for jobs such as this, but it's a little too large, and I would end up sacrificing part of this. So I got out my big old bull nose center. I know it looks like a bit of overkill, but I think that will keep it from backing out. Now let me get the tool set up. I like to go into fair detail on how I'm going about setting up a job. Alright, it's the next day and I'm ready to go here. Bring that bearing up against it, tighten the quill, and I'm ready to turn it down just enough to clean it up. It doesn't matter what the diameter is. That zinc turned real nice, no problem at all. And I'll just face this off later, or even just belt sand, it doesn't really matter. And we've got an indeterminate amount there, but it's a little bit less than 1.5 inches, which is just fine. So I have to turn my attention to the main piece now. The original here is 3 inches long overall, and a 2-inch reduction to 1/2 diameter, and the head is 1 inch long. So I've already taken the 2-inch stock and faced one end, marked it here at 2 inches right there. So I'll turn it down to 1/2 inch diameter up to that point. Now everything from here on out, oh, those don't show up at all, is waste stock and just to be used to hold it in the chuck. So back to the lathe. The work is mounted in a big 3-jaw chuck. I've already got it marked, or I scribed it here. Perhaps you can see the scribe line. And I like to use the carriage stop. You don't have to, but it just allows you to come up to the shoulder each time quite accurately. So that's already been preset and it's ready to go. Okay, this is the last pass. Okay, I'm within 5/1000ths, which is close enough. I just want to be near 1/2 inch so it will fit in a Jacob's chuck. I'm at 502/1000ths, which is just fine. 2 inches long. Now, in all of my videos, I emphasize order of operations. You can vary a little bit from this, but this works for me. So the next step is to cut off the excess, so I only have 1 inch left. And I'll do that in the bandsaw off camera. Then put it back in the lathe, holding it by the shank, face it, and proceed to bore it out. And then I also have to drill a hole all the way through. I'll probably do that first. I am extremely hesitant to show this operation, but sawing off using a portaband, machine running in reverse, cuts the cutoff time by tenfold, really, tenfold. And now to face off the body to a length of 1 inch. For now, I am drilling 5/16. That's all the larger I think it needs to be. I can always open it up at some other time during my life. Next, and before boring, I like to go in with several different sizes of end mills to a depth of about 9/16, working my way up to about 7/8 or so, and it's easier to get the boring bar started. This is my sample, but the reason I went in there with an end mill, first of all, is it gives you a flat bottom hole. And secondly, it opens up the hole large enough to where I can get in there with the boring bar diameter that I intend to use, which is this solid rock machine shop boring bar given to me by Steve Barton. So we'll see how that cuts. Let me get that set up. The boring bar is mounted in an Aloris holder, and it's choked up. Do not allow any more sticking out of the holder than necessary. It's on center, and I'm ready to take a trial cut. I guess I forgot to tell you that I'm using the carriage stop as always with this type of operation because I am boring a blind hole. Well, I'm getting close, so I'm measuring often. I'm about 25/1000ths from the final size, and at this point I like to switch to a telescoping gauge and a micrometer rather than a caliper, but of course that's your preference, and just creep up on the dimension, allowing always for a little flex in the boring bar and taking every other cut without increasing the feed. And in the last clip I meant without changing the depth of cut. And it's just about going in, so I have one or two more light passes and I'm at the dimension. I'm home. Okay, 3/1000ths to go, so this will be my last pass. Starting to go in. So I'll use Loctite. I'm putting it in backwards right now, and you can see that it's just a hair too deep. So I will face off a 1/16 or so, such that it'll be about flush, while I still have it in this setup. You know what? I have no intentions of turning this down to a smaller size. It will remain at 2 inches. Notice that I just chamfered that corner, and I'll chamfer the back one too. I'll just polish it up a bit, because that gives me about the right thickness there for my set screw. A little bit of a burr on the inside, and I think I'll open up the hole just a little bit to 1/2 inch diameter, maybe a 1/8 inch deep or so. There it is, I'm just about done. And you can see that solid rock boring bar just did a beautiful job, didn't it? And the zinc slug will fit in there really just nicely. So what I'm going to do now is put some Loctite on there and go eat lunch, and then come back and drill and tap the final hole for holding the die in place, and then the job is done. I'm at the Bridgeport, and this may be overkill. This could be done on any drill press, I guess. I'm just drilling and tapping a hole here, but I start out by having located the work with the center finder and an edge finder. It's 2 inches in diameter, and I went in about 1/4 inch, and there's a center drill. And then I'll drill 5/32 and tap 10/24. I don't need to show all of that. I'll probably drill a bit of a clearance hole in there too, because that's too long of a thread. Alright, I'm all done, and several things I noticed here. First of all, that not all of the hex dies are the same thickness, although this is a pipe thread, which would make it a little thicker, but they seem to vary just a little bit. Also, the hex dies do not offer the little depression or dimple for a set screw. So they simply go in and catch on any one of the flats, but they can't turn. Like the round ones can slip on you if you don't have that set screw in the dimple. So here we tighten her down, and it's ready to go. And now it's part of my arsenal of die holders. Probably worked out better for me than to try to use this hardened socket. And I would have found a 6-pointer, not a 12-pointer, but it would have worked. So there it goes. 1/2 inch diameter, 3 inch long, 1 inch, 2 inch, and about a 5/16 or a 3/8 hole. That can always be opened up if necessary. Ready to go. You have all the dimensions in this video if you desire to make one of these. You don't need a blueprint or anything like that. Hope you enjoyed the video, at least some of the operations here can be used in other projects that you do in your home shop. This is tubalcain saying so long for now.